Alright, so today what we're gonna do, if you remember, on Johannesburg router, we configured gigabit Ethernet 0/0 with IP 10.1.1/24. So now today we replaced that single interface with sub interfaces, which is what we call router on the stick, or what we call SVI, or layer 3 switch, so that G 0/0 now handles all three VLAN subnets. So the 10.10.1 dot something, and then 10.10.2 dot something, and then 10.10.3 dot something through the physical cable. Today we add something very powerful to our existing enterprise network, because so far what we've done, we've built a WAN connection, Johannesburg, Cape Town, Durban. Now the Johannesburg office has one LAN, which is the 10.10.1.0/24 network, where every department, like the finance, the HR, actually I've got something here, and the IT, is all on the same flat network. So one subnet, so everyone can talk to everyone. So today we are going to change that, and then we are going to take that Johannesburg LAN and segment it into three separate VLANs, one per department. And I just want to explain that deeply, why this is necessary before we touch a single command. If you check our topology, existing topology, router 1, Johannesburg, is connected to switch. Actually, I wanted to bring back this. So it's actually connected to switch Johannesburg 01 with all the PCs on 10.10.1.0/24 subnet. So this is what exists. This is what actually exists that we created before. So look at this topology right now. Every device on Johannesburg HQ, finance, HR, shares the same subnet of 10.10.1.0/24. A finance PC at 10.10.1.10 can ping the HR server at 10.10.1.50, for example, directly with zero obstacles, right? And this is a serious problem. Let me give you three reasons. Problem one is security. A flat network gives every device equal access to other device. So a finance employee's PC can send traffic direct to the HR server, and then the IT management server, and everything else on that 10.10.1.0/24 network. So they do not need to be malicious. Then let's say maybe a misconfigured application or ransomware infection, or maybe a compromised device in the finance can just spread laterally to every other department in seconds, because there's no walls, there's no doors, just total exposure. Problem number two is a broadcast domain pollution. Now every device on 10.10.1.0/24 is in the same broadcast domain. So when any PC does an ARP request, like for example it says who has 10.10.1.50, that broadcast goes to every single device on the subnet, and then a 200 device flat network generates thousands of broadcasts per second. We understand now. So every device must process each broadcast, consuming CPU, even if the broadcast is irrelevant to them, right? So VLANs create smaller isolated broadcast domains, and then the finance broadcast stays in the finance, HR broadcast stays in the HR. And then now again, problem number three is about compliance failure. Now section 19 of POPIA Act, the Protection of Personal Information Act, Act 4 of 2013, requires organizations to implement appropriate reasonable technical measures to protect personal information. So that means that the HR payroll data, employee medical records, and maybe disciplinary files, sitting on the server reachable by the finance PCs on the same flat subnet is a direct POPI Act violation. VLANs are technical measures that will fix this. All right. Now, talking about POPI Act POPI Act 4 of 2013, a responsible party must secure the integrity and confidentiality of a personal information and its possession or under its control by taking appropriate and reasonable technical and organizational measures. Now, VLANs are the most fundamental network layer technical control just to meet this requirement in a South African enterprise. So we have three problems: security, broadcast pollution, POPI Act compliance. Now, VLAN solve all three. Now, let me explain what VLAN actually is at a hardware level before we configure anything. Now, let's just go back here. Now, a VLAN or a virtual local area network is a logical partition rather. It's a logical partition of a physical switch. One physical switch, multiple independent broadcast domains, so each with its own subnet. Here's how it works at the highest level. Every Ethernet frame that passes through a VLAN, our switch carries an 802.1q tag or a 4-byte header inserted into the frame. So that tag contains a 12-bit VLAN ID, right? So VLAN ID run from 1 to 4094. So the switch reads the tag and only forwards the frame to the port in the same VLAN. So a frame tagged VLAN 10 or VLAN 10, the finance frame, right, will never reach a port in VLAN 20 or VLAN 30. So the switch hardware enforces this. So let me give you an analogy so that you can actually understand. Let's say an office building, say in Sentin. So think of Sentin Tower, Sentin City office towers, one physical building, but each floor belongs to different company, right? So law firm on floor 5, accounting firm on floor 6, IT company on floor 7, So the lift, which is, they say the lift now is a switch. It moves people are the frames between the floors, but the access control system, which is our VLAN logic, only lets you enter your own floor. You cannot walk, from the law firm into the accounting firm without going through the building's reception, which is the router. So that is exactly what VLAN do. All right. So before we configure anything, you must understand the two port types. So this is where the concept that where everything else builds on. So I just wanna completely quickly do this. The access port, one VLAN, not text, connects to the end device, and then the trunk port, there's multiple VLANs, 802.1q tags on every frame. It connects switches to switches or switches to routers. So a simple log that is now we need to go and update our transpect topology for the VLANs. So already we've got so you should have a router RTR JHB1, right, and then switch JHB1, which we have, all right, and then a few PCs. I've got PC1. So all of them, they're on the so we had to manually assign IPs, and then you can see here is they are all on the 10.1.0/24 network, plus the WAN links to Cape Town and Durban. So this is our starting point, or rather we continue from what we've built. All right, so we're going to expand the Johannesburg LAN, and so we need to add a second switch. Then we add 2 more PCs, maybe 2 finance PCs, 2 HR PCs, and then 2 IT PCs. All right, and then the finance and the HR PCs connect to the switch, to the first switch, and then the PC connects to the IT PCs will connect to the second switch. Okay, let's go ahead and add another switch somewhere here. So I'm gonna add another 2960 switch, and then let's give it a name. All right, so it was just warning me that it's actually still booting. Okay, so this one we can say it's a SW JHB and then 2. So you switch number 2. Alright, then we can close this, then we have this. Okay, so I'm gonna zoom out a little bit so that I have more space. And then we need to put 2 more PCs. And devices. Let's put 1, 2. We can always rename them later on. All right, so and then we can connect these 2 guys through this switch here. Then we need to connect the second switch, the second switch via with a straight through cable. So not a straight through, but a crossover cable. Remember, the crossover is to connect devices that are similar. So we can just use a gigabit Ethernet 01 here, and then we're gonna just connect to here to gigabit Ethernet 02. Now, and this is important, we need to update the connection between the router and the switch number 1, because previously we just had a simple straight through cable for the single 10.10.1.0 subnet. Now this connection, this is the connection that needs to carry 3 VLANs. Okay, so it becomes a trunk link. Now the cable stays the same, but it is a straight through, but we need to configure both ends as a trunk. Okay, as a trunk. So the connection between Johannesburg router, which is gigabit Ethernet 0/0, and the switch Johannesburg switch 1, which is gigabit Ethernet 02, already exists, right? So we're just reconfiguring it. So the switch port becomes a trunk, and the router interface becomes the sub interfaces. So do not add a new cable in that one. All right, you don't have to add a new cable. Now let's go to the router, or rather let's go to the switch, and then we need to create 3 VLANs and then assign the ports. So we enable and then configure terminal, right? Then we're gonna create VLANs matching our address scheme, right? So we're gonna have VLAN 10, and then the name is finance, then we have VLAN 20, and then the name is HR, and then we have VLAN 30, and then the name is IT. Now we need to do the finance pieces on VLAN 10. So the subnet is gonna be 10.10.1.0/24. Now again, it will help if you've got a table like this. We're gonna do interface first. Interface first. Ethernet 0/1. Okay, yeah, it's fast, not fast. Fast Ethernet, and then switch port mode access, and then VLAN 10. Sorry, there is switch port. What did I do now? All right, let me just retype this. Switch. And then we can do interface /2. So these are the switch ports, all right? So meaning for finance PC, you're not gonna connect it on any port on your switch. You're gonna connect it on those ports that we are configuring. So we're gonna do port number 2, and so we do the same thing, access okay, because there's only 2 PCs. All right, then we need to do the finance. So the finance, we will use port 3 and 4. So again, interface first Ethernet, which is 0/3, and then so let's switch port mode access, and then here we'll do a VLAN 20. Then we need to do the same thing with a the interface port 4. So anyway, I'm just pressing the up arrow just to get that, so that we do this quicker. So there's VLAN 20 as well. All right. Now we need a trunk. So a trunk is actually a link that goes from the switch to the router. So it's called a trunk. Okay. So for a trunk, we will do interface gigabit Ethernet 0/1 right. Then we will say switch port mode trunk, and then now it's up. All right, and then we'll do switch port trunk allowed VLAN, which is 10, 20. I think there should be space here. 10, 20, and VLAN 30. Okay, I got a spelling of switch port somewhere here. I'm missing an H. All right. Now we also need a trunk to the router that carries all 3 VLANs to the router. So that will be interface gigabit 0/2. Ethernet 0/2. And then switch ports All right, so let me just highlight a key points here. So we have VLAN 10 for finance, and then matching the subnet of 10.10.1.0/24, and then VLAN 20 for HR, matching subnet 10.10.2.0/24, and then VLAN 30 for IT, matching subnet 10.10.3.0/24. So notice we deliberately matched the VLAN numbers to our subnets third octet. VLAN 10 for the .1 network, and then VLAN 20 for the .2 network, and then VLAN 30 for the .3 network. So this makes the design the design easy to understand and document. Now gigabit Ethernet 0/02, that's the uplink to the Johannesburg router. So it's now a trunk. Now this is a critical change from previously what we've done, because previously this port was a plain access port or just a routed interface. Now it carries all three VLANs, so that the router can route between them. So the port connecting the switch to the router is a router on a stick set up. It must be a trunk port, so it's always common. It's always a common configuration mistake just to leave it as an access point port. So if it stays as an access point, only one VLAN reaches the router, and the others are completely blocked. All right. Now let's go ahead and then go and configure switch number 2. So let's CLI. And then enable, and then configure terminal. So VLANs must be created on every switch in the network. So that's a thing. So we'll have to create VLAN 10, which is name is finance, and then VLAN 20, name is HR, and then VLAN 30, and then name is IT. All right, now, and then we need to do the IT PCs, which is VLAN 30 subnet. The subnet is going to be 10.10.3.0/24. Okay, interface fast Ethernet 0/1. And then switch port mode access, and then so the switch port access, my spelling is wrong. Alright, access, so that's VLAN 30, and then we can just do the same thing with fast Ethernet 2, and then we need a trunk back to the switch, to the switch number 1. So gigabit Ethernet 0/1, and then switch port trunk allowed VLAN all right. Now we can actually verify both switches by saying show VLAN brief. So you can do the same thing on then we can see the VLANs, the 3 VLANs here. So you can do the same thing on the other switch as well. So show the show VLAN brief output for switch 1. So for switch 2, we can see that VLAN 10 finance is on. Actually, this one is on FA01 and FA02. All right, now it's time for us to go and assign IP addresses. I think we're good. Now we need to configure all addresses on the 6 PCs. So I think we need 2 more PCs here, but let's just rename these PCs so that we know what's happening. So this one is gonna be IT PC1. And then let's give it an IP address. So I'm gonna go to IP configuration, and then let's give it an IP address which is, so it's 10.10.3.10, right? And then the subnet mask is gonna be 255.255.255.0, and then the gateway is gonna be 10.10.3.1. So first we give it a name, which is, we can just say IT here, IT PC2, and then let's give it so this one is gonna be 10.10.3.11, and then the subnet is gonna be 255.255.255.0, and the gateway is gonna be 10.10.3.1. These ones is gonna be PC1 and PC2. We can just rename it. Let's say maybe it's finance 1. So let's just rename and then change. So this one is gonna be finance PC1, and then let's go and change the IP configuration. So now we can have 10.10.1.10 or 10, and then the gateway is gonna be 10.10.1.1 on this one. I don't know what did I do here. I needed to, let me just change the name to finance. Oh yeah, I did change the name to finance P. Okay, so that's fine. All right, so this one is gonna be finance PC2, and then perhaps we need HR as well. Okay, let's just make this one. So it's gonna be finance PC2, and then let's go ahead and give it an IP. So this is gonna be 10.10.1.11, and then the gateway, I think it's gonna be the same, so it's fine. All right, so we need another 2 PCs for HR that we can connect to this switch. Let's just do this. I'm running out of space. Let's put 2 more PCs for HR. So let's put a PC here and a PC here. So this one we can somehow give it a name before. Okay, let's connect. Oh, let's give it a name first. Then maybe we can just connect. So this one is just gonna be let's call it HR PC1. PC1. Okay, maybe we use a hyphen here, and then let's give it configuration. So for HR, we will do 10.10.2.11, and then the subnet is 255.0, and then we have the router, the gateway is going to be 10.2.1. Okay, let's give it a name first. So that's HR PC2, and HR is going to be .11, 10.2.11, and then the subnet is .255.255.0, and then the is .2, so that .10.10.2.1. Okay, so that was HR PC2. Then we can connect them. So when you connect them, they go to 3 and 4, not any other port. So those are the ports that we actually configured. For finance, you configured port 1 and 2. So you must notice the default gateways is 10.10.1.1, and then 10.10.2.1, and then 10.10.3.1. So these actually matches our VLSM scheme from the design that we did initially. All right. So now the thing is, when we configure a router on the stick, the router sub interfaces will be assigned these exact IP addresses, and the gateways will automatically work, so we are just planning ahead. Now the best way to test this, we can just go maybe to finance PC1, and then so we are testing the isolation, and then we're gonna go to it's desktop, right? Looking for command prompt, and we will ping. So there is no router needed, so this should actually succeed. So if we ping 10.10.1.1.11, so this should actually succeed, right? So we get 4 out of 4. Perfect. So finance PC1 reaches finance PC2 directly at layer 2. So the switch forwards these frames within VLAN 10, right, without involving the router at all. So it's fast, it's direct and correct. Now the test 2 will be to ping 10.10.2.10, which is a different VLAN. So this is from finance PC1 to which pings HR PC1, which is 10.10.2.10. So this should actually fail. It should actually fail, and then you can see it's just timed out. The request timed out responses. All right. So now request timed out 4 times, and this is exactly what we want to see. The finance cannot read HR, right? Not because of the firewall, but not because of an ACL or anything like that, because the switch hardware will not forward the frame from VLAN 10 to VLAN 20. So the 802.1q enforcement is working perfectly. And then we can try IT as well. So we can try IT ping 10.10.3.10. So it should fail also. There we go. Also fails. Finance, HR, and IT are now 3 completely isolated networks. Even though they share the same physical switches, right? VLANs are working. So that means the POPIA compliance wins. So with VLAN active, HR payroll data on 10.10.2 is completely unreachable from finance PCs on 10.10.1 at the network layer. So most of the institutions, they actually use VLANs. So let's recap what we've done. We took our existing Johannesburg HQ network, and then the flat 10.10.1.0/24 that we did before, and then segmented it into 3 VLANs. VLAN 10 for finance, and then which is on 10.10.1.0/24, and then VLAN 20 for HR on 10.10.2.0/24, and then VLAN 30 for IT on 10.10.3.0/24. So the VLAN numbers match our subnet third octet, and and they deliberate. It's just a deliberate design choice for clarity. So we also configured access ports on both switches, and then trunk links between switches and between the switch and the router, and then we proved that VLAN isolation works. Same VLAN pings succeed, cross VLAN pings fail. But now finance cannot reach HR when they need to. So that is a problem of the next lesson that we will solve with inter-VLAN routing. So we're just gonna go back to the router and then transform it to G0/0 interface into 3 sub interfaces so that it can route between all 3 VLANs.